So hello everyone, today I'm going to show you how to solve a problem from gravitation without actually studying gravitation. So as the thing is, I have not studied gravitation in like 5 or 6 years, and I was solving some problems and I came across this one. So I was thinking how to do it, and I had no fucking idea. But the one thing I studied was electrostatics. So let's use those ideas. So this given that a spherical planet of radius r has a uniform density of rho. Okay. And it doesn't rotate. Good enough? If the planet is made up of some liquid, the pressure at point r from the center is. Okay. Now the thing is, whatever I remember from the electrostatics is the electric field at any interior point for a uniform charge distribution is E equals rho r divided by 3 epsilon naught. Good enough? Now I am going to tweak this equation a little bit. So we have E that will give me rho by 3 epsilon naught, okay, multiply 4 pi and divide by 4 pi. So what did we get? We get E equals 4 pi rho divided by 3 into 4 pi epsilon naught. And what we know is 1 by 4 pi epsilon naught can be used as K. And in gravitation we can use it as G, the gravitational constant. And what is R? Sorry, what is E? E is the force per unit charge. So if I replace 1 by 4 pi epsilon naught by G, I can make it acceleration due to gravity. That is basically force per unit mass, that can be called acceleration. So I can say G equals 4 pi rho G r divided by 3. Good enough? And this is basically okay. Now what is force? Force equals mg. Okay, this is given for any arbitrary planet, but I am using the concept of gravitation, which is good enough for this one. So F equals mg. So the force on that, like this would be the diagram. This is a uniform sphere, this is the center, this is the distance r, this is the total sphere, and we have to figure out what will be the pressure at that point. So what will be the force at this point? The force at this point would be 4 pi rho dF would be 4 pi rho G r by 3 multiplied by 4 pi r square rho dr. This is the volume element and this is the density again. So we are getting the force. So the pressure would be dP equals dF by A, that is dF by 4 pi r squared, and thus we get dP equals, we can take out the vector notation and we can use basically the scalar one, and what we get is 4 pi rho G r by 3 multiplied by 4 pi r square rho dr multiplied by 1 by 4 pi r squared. This gets cancelled out and we are basically left with dp equals 4 pi rho g by 3 r. Okay, there will be a rho square over here dr. Now we are to find the pressure at some point r. So let's say the distribution is from capital small r to capital R. So this will give me P, this will give me P. So P equals this one, so R to R, this thing is constant, so it gets out of the integration. So it gets out of the integration by 3 integral r to r dr, and the integration would be half capital R square minus small r square. So 4 pi rho squared g divided by 3 into half rho r squared minus r squared. So thus my answer would be two by 3 pi rho squared g capital R squared minus small r squared. And do I have an answer? Do I have an option for this one? Indeed I have. This is option C. And let's recheck 2 pi rho square g by 3 r square minus r square, and 2 pi rho square g by 3 r square minus r square. This is option C. So this is how you solve a problem from gravitation with elementary idea of electrostatics. I am signing off today.